The Cost Curves According to Betta Fish by Kyoka Millard, Hannah Paulson, B. Rain Paulson, Lizzie Plaumitis, and Greg Amusu.
Once upon a time, there was a man named Greg Amusu who got accepted into the Harvard School of Business. Soon after, though, he realized that his true goal in life was to breed betta fish. So, he dropped out of Harvard in order to pursue his dream. However, in order to make a living, he would have to sell his betta fish as well. But selling betta fish was no easy business. He realized that he would have to figure out how to make profits in his short-run market given the cost of breeding his fish. It was time to hire some economists, Brian, Hannah, Kyoka, and Lizzie, to help him succeed in his betta fish business.
Alright, we should look first at something called average total cost for your betta fish farm, Hannah said. However, Greg had already learned a thing or two about average total cost during his brief stint at Harvard. Average total cost is a crucial aspect in determining what course a business should take in the short run, said Greg. If price is greater than average total cost, then the firm earns positive economic profit per unit. If the price is less than average total cost, the firm incurs a loss or negative economic profit per unit. If price is equal to average total cost, then the firm is breaking even. Okay then, since you know so much about average total cost, explain the graph to me, Hannah said. Okay, said Greg. Typically, average total cost decreases with additional production at small quantities of output, then increases with relatively large quantities of output. This pattern is illustrated by a U-shaped average total cost curve.
Although Greg knew a lot about average total cost, he still needed help with total cost. He decided he would have to swallow his pride and asked Lizzie about it. Total cost is the full cost of producing any given level of output, or average fixed cost plus average variable cost, which you will learn about later, said Lizzie.
Kyoka told Greg that he would need to worry about his marginal costs as well. Marginal cost is the difference in total cost from breeding one more betta fish, she said. For example, if you had 3 betta fish and it cost you $40 to breed them, but you wanted to breed another fish, you would look at how much it would cost to breed 4 fish. Then you would subtract $40 from this amount to find the marginal cost. As a visual, let's look at the marginal cost curve on a graph, Kyoka said. As you can see, it is U-shaped because of something called the diminishing marginal return. Diminishing marginal returns means that eventually, if you continue to breed one more betta fish while keeping your other factors of production constant, you will find yourself with lower returns. Basically, you shouldn't just produce as many betta fish as you can because it doesn't always equate to a higher revenue.
Brian went on to explain average variable cost to Greg. It's pretty simple, he said. To find the average variable cost, you just have to divide the variable cost by the number of units produced. Greg replied, okay, if my variable cost for producing 10 betta fish is $30, my average variable cost per betta fish is $3? Yes, exactly, replied Brian.
Then B. Rain said to Greg, variable cost is the cost that depends on the quantity of output produced. In other words, it's the variable cost of input. Greg took a moment to write this down. Brian continued, because of the law of diminishing marginal returns, for every additional unit of input bought, a firm produces increasingly less output. He went on to explain the variable cost curve is exponential because the cost per unit of input remains the same, but the firm gets less and less out of it. Brian explained to Greg that if he hired workers in his betta fish firm, labor would be a variable cost, because Greg could have to hire more labor as he produced more fish. Brian warned Greg, but if you hire too many workers, their marginal productivity will decrease because of the law of diminishing marginal returns.
Next, Greg would have to look at average fixed cost. He turned to Lizzie for advice. Average fixed cost is the total fixed cost divided by the quantity produced. So for Greg, the total fixed cost would be his total cost of the building that Greg breeds and sells his fish in. Then he would divide that by the number of betta fish produced, said Lizzie. In other words, average fixed cost equals the total fixed cost divided by the quantity.
Hannah then proceeded to talk to Greg about the fixed costs he would have to face in his firm. A fixed cost, she said, is one that does not depend on the quantity of output produced. It is the cost of the fixed input and is sometimes referred to as the overhead cost. In Greg's firm, an example of a fixed cost would be the building that Greg breeds and sells his fish in, because he only has to pay for the building once, no matter how many fish he produces, in the short run. She explained that on a graph, fixed cost has a slope of 0, because the cost does not increase when more output is produced. She also said, fixed costs include implicit and explicit costs. An example of an explicit fixed cost is the building you're breeding fish in. An example of an implicit fixed cost is going to Harvard School of Business.
After much help and assistance from his team of fabulous microeconomic connoisseurs, Greg was able to successfully pursue his dream of owning a betta fish breeding enterprise. His economists taught him about average total cost, marginal costs, average variable cost, total cost, fixed cost, and average fixed cost. Kyoka and Lizzie warned Greg that if the average total cost exceeded the market for his betta fish, he would incur economic losses. Hannah and B-Rain commented that Greg were to produce at a level where market price is equal to average variable cost, he would break even, earning only normal profits. However, Greg outsmarted all of them and produced at a level where market price far exceeded average total cost, garnishing him a profit.